Welcome to Space Mysteries, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button and turn on notifications so you never miss an update. Have you ever felt the ground shake? That's the Earth reminding us it's alive and always changing. Our planet is made of giant puzzle pieces called tectonic plates, which move slowly until they get stuck and suddenly snap free. That violent release is an earthquake, sending energy through the ground, shaking buildings and cracking roads. Now imagine this happens under the ocean. The seafloor jolts, pushing up a massive amount of water. This creates a tsunami, a series of huge, fast-moving waves, nothing like the ones you see at the beach. Tsunamis can cross entire oceans, growing into towering walls of water as they reach the coast. Earthquakes and tsunamis are linked, and understanding them helps us predict and prepare for disasters. Science turns fear into knowledge, giving us tools to protect ourselves. Today, we'll explore one of the world's most powerful earthquake zones, the Kamchatka Trench off Russia's coast. This area has a megathrust fault, capable of producing some of the biggest earthquakes and tsunamis on the planet. These quakes can send waves across the Pacific, threatening places as far as Hawaii and California. Studying this fault helps us understand the risks for millions living around the Pacific Ring of Fire. The Kamchatka Trench is a key to understanding global tsunami threats. Let's dive in and discover how this powerful feature shapes our world. The ground beneath us is more dynamic and more dangerous than it seems, and by understanding it, we can be ready for whatever comes next. What makes a megathrust fault so special? Let's break it down. A regular fault is a crack where two blocks of rock move past each other, sometimes slipping and causing earthquakes. A megathrust fault is the heavyweight champion. It's where one giant tectonic plate slides beneath another in a process called subduction. Imagine pushing a thin mat under a heavy rug. The mat bends and scrapes, building up stress. The area where they stick is the megathrust fault, sometimes hundreds of kilometers long. When it finally slips, the energy released is enormous, enough to create magnitude 9.0 earthquakes. These are the most powerful quakes on Earth, releasing tens of thousands of times more energy than smaller ones. Famous examples include the 2011 Japan and 2004 Indonesia earthquakes, both megathrust events that triggered devastating tsunamis. Because these faults are underwater, the sudden movement of the seafloor displaces huge volumes of water, creating tsunamis. A megathrust fault is a vast underwater boundary where immense pressure builds up over centuries. When it releases, the results can be catastrophic for coastlines thousands of kilometers away. That's why scientists pay close attention to the megathrust near Russia. Its history and potential make it one of the most closely watched faults on the planet. Understanding megathrusts is the first step to understanding global tsunami risk. Let's find this megathrust fault on the map. Look northeast of Japan and you'll see the Kuril Islands stretching up to Russia's Kamchatka Peninsula. Just offshore is the Kamchatka Trench, one of the world's deepest ocean trenches. This region is part of the Pacific Ring of Fire, a zone of frequent earthquakes and volcanoes. Here, the massive Pacific Plate dives beneath the Okhotsk Plate, forming a subduction zone over 2,000 kilometers long. Kamchatka itself is a land of fire and ice, with over 160 volcanoes, about 30 still active, thanks to this subduction. The same forces that create volcanoes also cause massive earthquakes and tsunamis. The Kamchatka Trench is a local fault with global consequences. Any major quake here can send tsunamis racing across the Pacific, threatening countries far beyond Russia. Its location makes it a concern for every Pacific coastline. This is why scientists study it so closely. The Kamchatka Fault is a sleeping giant with a reach that spans oceans. Understanding its geography is key to understanding its threat. Why is the Kamchatka Fault so dangerous? Its history tells the story. This fault has produced some of the world's largest earthquakes, including a magnitude 9.0 event in 1952. That quake unleashed a massive tsunami, with waves up to 15 meters high, devastating coastal towns like Severodvinsk. The tsunami didn't stop at Russia. It crossed the Pacific, damaging Hawaii and even reaching California and New Zealand. The fault's length allows huge sections to rupture at once, and its geometry is perfect for launching tsunamis. Its history shows a pattern of repeated giant earthquakes. The danger is not if, but when, it will strike again. The 1952 event was a wake-up call. One quake here can threaten the entire Pacific. The fault stays quiet for decades, building up stress, then releases it in a global event. Scientists call it a sleeping giant because it's overdue for another major quake. Its silence is deceptive. The longer it sleeps, the bigger the risk. Monitoring this fault is crucial for global safety. The Kamchatka Trench is a reminder that nature's most powerful forces can awaken at any time. Understanding its past helps us prepare for its future. The world is watching, and for good reason. How do scientists know this fault might be ready to rupture? It's all about seismic gaps. A seismic gap is a section of a fault that hasn't had a major quake in a long time, while nearby sections have. These locked zones are where stress is building up, making them likely spots for future earthquakes. In the Kamchatka Trench, scientists have mapped out these gaps by studying past quakes. Some segments have been quiet for centuries, accumulating pressure like a wound-up spring. To monitor this, scientists use seismometers to detect tiny tremors and GPS stations to measure ground movement down to millimeters. The data shows the land is being squeezed, meaning the fault is locked and storing energy. These seismic gaps are the most likely places for the next big rupture. While we can't predict the exact moment, the evidence suggests some segments are in the late stages of their earthquake cycle. The clock is ticking. The longer the gap, the greater the risk. This scientific detective work helps us prepare for what's coming. It's not guesswork, it's careful measurement and analysis. The Kamchatka Fault is primed for a major release of energy. Understanding these warning signs is key to disaster readiness. The science is clear, we must be prepared. What happens if a seismic gap in the Kamchatka Trench ruptures? First, a massive earthquake, possibly magnitude 8.5 or higher, would shake the region for minutes, causing landslides and severe damage. But the real danger is the tsunami. The seafloor's sudden movement would send a wall of water racing toward the Russian coast within 30 minutes. Waves could reach 15 to 20 meters, devastating coastal communities. The tsunami wouldn't stop there, it would become a tele-tsunami, crossing the Pacific at jetliner speeds. Within hours, waves would reach Japan, Alaska, Hawaii, and eventually the Americas. Even after traveling thousands of kilometers, these waves could still cause catastrophic flooding and destruction. The entire Pacific basin would be at risk from a single event. That's why the Kamchatka Fault is a global concern. How does an earthquake create a tsunami? It's all about energy transfer. On a megathrust fault, the oceanic plate is stuck under the continental plate, bending it downward. When the fault ruptures, the continental plate snaps upward, lifting the seafloor by several meters. This sudden movement pushes up a massive column of water, creating a bulge on the ocean's surface. Gravity pulls the water back down, sending waves outward in all directions, the birth of a tsunami. In the deep ocean, the tsunami wave is barely noticeable, maybe a meter high, but it travels at jet speed. Ships at sea might not even notice it passing beneath. As the wave approaches land, it slows down and grows taller, turning into a towering wall of water. A wave that was small in the deep ocean can become a 20-meter monster at the coast. This is why tsunamis can appear suddenly and with devastating force. The transformation from subtle wave to destructive surge happens in minutes. Understanding this process is crucial for early warning and survival. The science behind tsunamis helps us know when and how to act. We've seen the devastation megathrust earthquakes and tsunamis can cause. The 2011 Tohoku earthquake in Japan, a magnitude 9.1 event, triggered a tsunami up to 40 meters high, wiping out entire towns and causing the Fukushima nuclear disaster. Even with advanced warning systems, the destruction was immense and the loss of life tragic. In 2004, a magnitude 9.1 quake off Sumatra generated a tsunami that killed over 230,000 people across 14 countries. The lack of a warning system in the Indian Ocean made the disaster even worse. These events proved the immense power of megathrust-generated tsunamis. They show that proximity to the quake means little time to react. Local preparedness is essential. They also highlight the importance of robust, ocean-wide warning systems. Past disasters are not just history, they're lessons for the future. They teach us how to prepare, respond, and survive. The echoes of these tragedies remind us to listen when the Earth speaks. We must use their lessons to protect ourselves from the next big one. So, what can we do to stay safe from threats like the Kamchatka Trench? The Pacific Tsunami Warning System is our first line of defense, using seismographs and deep ocean buoys to detect tsunamis and issue alerts. When a large undersea quake is detected, warning centers analyze the data and send out watches or warnings to countries around the Pacific. A watch means stay alert. A warning means take immediate action. If you're in a coastal area and feel strong, long shaking, don't wait, head to high ground immediately. Know your community's evacuation routes and have a go bag ready with essentials. Practice your plan with your family and know where to go before disaster strikes. Listen to local officials and pay attention to natural warning signs, strong shaking, a loud ocean roar, or the sea suddenly receding. Science gives us the warnings, but it's up to us to act. Preparedness saves lives. By turning knowledge into action, we can face even the most powerful forces of nature. Stay informed, stay ready, and stay safe. The more we understand, the better we can protect ourselves and our communities.